Good morning. We're going to be working on finding probabilities or areas or percentile ranks for the normal distribution. This is page 100 of the note spiral, and we're going to be doing parts C and D. All right, part C and D. All right, first off, to review our scenarios, compute the z-scores and calculate the probabilities for the following. Life expectancy for a particular brand of light bulb is normally distributed with a mean of 1,500 and a standard deviation of 75. And once again, the only reason I can use the table is because I know that this is normal. We can calculate z-scores of anything. We can only use the table if we're working with a normal distribution, all right? So please don't make that confusion. So only can use the table. Z-scores for anything, but normal distribute, you can only use a table if it's normal. All right, so what's the probability that a light bulb will last between 1,563 and 1648 hours? All right, so real quickly, I have a mean of 1,500, and then they want me to figure 1563 and 1648. So they're looking for this area right here. And I don't know if I have those in the right place. All I know is they're above the average, they're above the mean, so I wrote them above the mean. That's the only thing that I can truly speak to at this point. So, all right, how am I going to do this? Well, I'm actually going to have to break this into like two parts, and I always start with the larger value first, which in this case is 1648. So I'm going to do a z of 1648. And I'm going to do a z of 1563. And what they're really looking for is the probability that 1563 is less than x is less than 1648. That's what we're really looking for. So I always start with the larger value first. So z equals x minus mu over sigma. We know that, so I'm going to plug in. In this case, I get 1,648 minus 1,500 divided by 75. And I don't know if, let's do this off to the side. So 1648 minus 1,500 divided by 75 equals about 1.97. It's approximately 1.97. The table is only good to two z-scores. So remember, it's working left to right. So this is the probability that z is less than 1.97. All right, using the positive z-score table. 1.97 is right here. So I end up with 0.9756. So that's the first part. That's the first part of this problem. Okay. Now, moving on to the second part, I need to do the same thing, but for 1563. So 1,563 minus 1,500 over 75. And when I run that through the calculator, let me slide this up so you can see it. So I end up with 63 divided by 75, and that's 0.84. So the probability that z is less than 0.84. All right, so once again, looking at my table, that's an easy one because it's right on the edge. I end up with 0.7881. I'm going to subtract those. And I end up getting 0.1875. So the probability that 1563 is less than X is less than 1648 equals 0.1875. All right. So that's where that lies. Now, let's real quickly look at the z-score and what we were doing. We calculated that first z-score. This was our mean, was 1500, and we ended up getting a z-score with the 1648. So I'll put the 1648 here. And we ended up getting a z-score that was associated with that 1648 of 1.97. And so we found this area all the way back to negative infinity, but I really didn't want that. Okay, so we also had the 1563, which let's just say it was right there. And we calculated that z-score at 0.84. And we calculated all the area behind that. And so I subtracted the blue from the 1648 value, and that's what gave me my solution, which is right in there. Okay, so you have to do one, then do the other. So let's try another one just very similar to that one, which is part D. All right, so what is the probability that the light bulb will last between 1416 and 1677 hours? Well, once again, we still have a mean of 1500. We still have a standard deviation of 75. And we're looking for the probability that this bulb is going to last between, less than X is less than 1677. And if you want to make it less than or equal to, that's fine. It doesn't matter. It really doesn't. We can talk about that at a later time. So once again, Z equals X minus mu over sigma. So plugging in, and I always start with the larger value, which is 1677. So 1677 minus the 1,500 over 75. 1677 minus 1,500 divided by 75. Try that again, divided by 75. And I don't think I did that correctly. 2.36. So I'm looking for the probability that Z is less than 2.36. And I kind of got ahead of myself. I left off something very, very important. So off to the side right here, I'm going to draw what I was looking for. What I'm looking for is this. Here's 1,500. And we have 1677 up here and 1410 somewhere below. And I'm looking for this entire area right here. That's the area I'm looking for. When I calculate the 1677, it's going to shade it all the way down, so it's going to look like this. Then I'm going to need to subtract out the 1410 area to get the part that I want, because I want this part. So I calculate 1677, which goes all the way to negative infinity, and then I'll subtract out the 1410, and I'll have what I want. So we calculated the 1677, except I haven't figured out the probability, so I need my table. Looking at a positive, because it's a positive z-score, looking for 2.36, 2.36, 35, 36, which is point, you can't see that. Let me slide that up. So 30, 31, 32, 33, 34, 35, 36, so 0.9909. So the probability that Z is less than 2.36 equals 0.9909. Now I need to calculate the same thing for 1410. I'm going to try to give myself a little more room this time. So 1410 minus 1500 over 75. So I'm going to end up with a negative Z-score. And that makes sense because 1410 is below the average. And when I do that, I get a negative Z-score of about negative 1.2 equals negative 1.2. So the probability that Z is less than negative 1.2 equals, and I need my negative Z-score table, make sure you have the right one, all right, is 0.1151, 0.1151. Did I calculate that one? Let me recheck my math. I think I may have made a mistake. 1410. Negative 1.2. Correct Z-score. 0.1151. All right. I subtract those. I get 0.9909 minus 0.1151. And I end up getting 0.8758. So the probability that we would have a light bulb last between 1416 and 1677 equals 0.8758. In other words, we can say about 88% of the light bulbs last between those time frames. So 87.58% of the light bulbs last between 1,416 hours and 1,677 hours. Thank you for that.